The opposite for resistors. So take note of that. Resistors are connected in parallel when we need a resistance less than that is available. Now tell me, if I have two resistors R1 and R2 in parallel, what will be the total resistance of the combination? Well, the total resistance can be obtained by solving this equation for R. If two resistors R1 and R2 are connected in parallel, and if R is the total resistance, then 1 over R equal to 1 over R1 plus 1 over R2. Can you solve this for R? Well, the right hand side can be simplified by taking R1, R2 as the common denominator. Then the numerator becomes R1 plus R2. So 1 over R equal to R1 plus R2 over R1 plus R2. Therefore, what is R equal to? R equal to R1 R2 divided by R1 plus R2. A similar situation we saw in the case of capacitors connected in series. Two capacitors in series gives you a total capacitance of C1 C2 over C1 plus C2. Similarly, two resistors in parallel gives you a total resistance of R equal to R1 R2 over R1 plus R2. A very important relation. If you remember, problem solving becomes very easy. A simple problem. A 1 ohm, a 2 ohm and a 3 ohm are connected in parallel. What is the total resistance of the circuit? Alright. Well, we go directly to the equation. 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3. And R1 is 1 ohm, R2 is 2 ohm, R3 is 3 ohm. So that will be 1 over 1 plus 1 over 2 plus 1 over 3. That is 11 over 6. If 1 over R is 11 over 6, then R equal to 6 over 11 ohm. Now remember, the equation we use for two resistors cannot be used for three resistors. The equation R equal to R1 R2 divided by R1 plus R2 is only for two resistors. You cannot extend that equation for three resistors. When you have three resistors, you got to come in and use the normal equation. Alright, let's do, so the total resistance actually, when two resistors, 2 ohm and 3 ohm are connected, you can see that 1 ohm, 2 ohm and 3 ohm are connected in parallel. The total resistance is less than the smallest of the three. You see? So when do we connect resistors in parallel? When you want a smaller value than the ones that you already have. Another problem. The current in a looped circuit that has a resistance R1 equal to, the current in a looped circuit has a resistance R1 and the current is 2 ampere. The current is reduced to 1.6 ampere when a resistor R2 equal to 3 ohm is added in series with R1. What is the value of R1? Well, look at the diagram here. The current in a loop circuit. You understand what a loop circuit is? A closed circuit. The current in a loop circuit that has a resistance R1 is 2 ampere. Obviously, the circuit has a cell that provides the potential difference. We are not interested in the value of the potential difference. So, the current in the resistance R1 is 2 ampere. What did we now do? The current is reduced to 1.6 ampere when a resistor R2 equal to 3 ohm is added in series with this. when a resistor 3 ohm is connected in series with it, the current is reduced to 1.6 ampere. We need to find the value of R1. So if V is the potential difference across R1, we can write V equal to 2R1. Is that right? The potential difference across the resistance is V equal to 2R1. Why? V equal to IR. Our I equal to 2 ampere. Alright, now look at the second situation. What did we do? We connected a 3 ohm resistor in series with it. Tell me, what is the total resistance now? When a 3 ohm is connected in series with R1, the total resistance is, alright, tell me what it is. The total resistance is R1 plus 3. When resistors are in series, they add up. So the total resistance now is R1 plus 3, and the current is now 1.6 ampere. Now, has the total potential changed? No, the total potential is provided by the cell. That hasn't changed. So the current now is I equal to 1.6 ampere. But the voltage V remains the same across the combination. And that voltage V is provided by the cell. So can you write an equation for this voltage V when the resistors are, the total resistance now is R1 plus 3? Well, it will be V equal to IR, where R is the total resistance, R1 plus 3. So V equal to 1.6 times R1 plus 3. If you now look at these two equations, V equal to 2R1 for the first circuit and V equal to 1.6 times R1 plus 3 for the second circuit, V is the same. So what do? We can now equate the right hand sides. Right. The two equations of V can be used to find the value of R1 by equating the right hand sides as 2R1 equal to 1.6 times R1 plus 3. And I'm going to leave that for you to solve. Can you? Well, I've got the right step for you. 2R1 is 1.6 R1 plus 4.8, and moving the 1.6 R1 to the left, you get 0.4 R1 is 4.8, or R1 is 12 ohm. That's a good problem, and I would like you to practice this kind of problems. Another one. Find the total resistance between point A and B. That's point A, and that's point B. Find the total resistance between points A and B in the diagram. If the potential difference between A and B is 12 volts. In other words, if I now connect a cell between points A and B of EMF 12 volts, find the potential difference across each resistor and the current in each. Okay, let's first start looking at the total resistance. Where do we start? We start at this parallel combination. Can you tell me what is the total resistance of this parallel combination? When two resistors are connected in parallel, the total resistance will be R1 R2 divided by R1 plus R2. So the total resistance of this parallel combination is 7 times 10 divided by 7 plus 10. So first we find the equivalent resistance of this parallel combination using this formula R equal to 7 times 10 divided by 7 plus 10, that is 4.12 ohm. So this is now 4.12 ohm. This is now equivalent to a 4 ohm, a 4.12 ohm, and a 9 ohm in series. So now we have a 4 ohm, a 4.12 ohm, and a 9 ohm in series. What is the total resistance? The total resistance of a series combination is the sum of the three. Alright, so this circuit is equivalent to the original circuit. What is the total resistance? It will be 4 plus 4.12 plus 9 equal to 17.12 ohm. That is the total resistance. Okay, now what do we have? We are told that there is a potential difference of 12 volts between A and B. That means there is a potential difference of 12 volts across the combination of resistors. Let's go to the next slide. So if the potential difference between A and B is 12 volts, well, the potential difference here is 12 volts. And what is the total resistance here? We calculated the total resistance. That will be 17.12, is that right? Now, we have a V equal to 12 volt. The total potential is 12 volt. The total resistance is 17.12 ohm. If you know the total potential and if you know the total resistance, can you find the current in the circuit? Well, I equal to V over R. That gives me V is 12 volt, R is 17.12 ohm, and that is 0.7 ampere. Now, that means, suppose this is the battery here. Let me go and draw the battery there for you. Now, suppose there's a battery in here. This is A, that's the battery there. And that battery is a 12 volt battery. Now, you must understand what this means is the battery now drives a current of 0.7 ampere. And when it comes over here, tell me what is the current flowing in the 4 ohm resistor? That 0.7 will flow in the 4 ohm, but when it comes here, that 0.7, part of it will go through the 7 ohm, part will go through the 10 ohm. They will come here, combine to become 0.7 in the 9 ohm. Is that right? Well, I hope you understood that. Well, let's continue. Now, this is the total current in the circuit. To find the current in each resistor, we go to the first diagram. Alright, this is the first diagram. Let's now find the current in each resistor. The total current we know is 0.7 ampere. That means the current in the 4 ohm will be 0.7 ampere. There you are. That is 0.7 ampere. And that 0.7 ampere comes to this point. What happens? Well, let's first of all find the potential difference across the 4 ohm. You know that the current in the 4 ohm is 0.7 ampere. The resistance is 4 ohm. The current is 0.7 ampere. Can you find the potential difference across the 4 ohm? Well, V equal to IR. You know the current, you know the resistance, so that will be 0.7 ampere multiplied by 4 ohm. That is 2.8 volt is the potential difference across the 4 ohm. Alright. How about, let's go now to the 9 ohm. What is the current in the 9 ohm resistor? When this 0.7 comes here, it will split into one part going through 7 ohm, the other part going through 10 ohm. They will combine and will become 0.7 ampere in the 9 ohm. So the current in the 9 ohm resistor is 0.7 ampere. So can you find the potential difference across the 9 ohm?